My name's Kathleen, and I work on the Hive team in Los Angeles. I'm here to talk to you today about components and plugins and their importance to good software design. Component-oriented design is what Hive uses to break up our code base. It's not mutually exclusive from object-oriented design, but the motivation is a little bit different. Component-oriented design enables the swapping of functional units in our code. So, what is a component? A component is a reusable, interchangeable object that provides functions. A component can store data, but the main purpose is to do something. For contrast, if you've ever studied object-oriented design, you might be familiar with the classic employee data class example. These objects hold information about an individual employee, such as their name, what department they work in, their job title, and that's the main purpose of those objects. Components can hold information like that, but their main purpose is to take in data, do something to it, and produce output. The input and output parts of this are defined by an interface, which allows us to do really easy swapping of the do stuff part. Here are some everyday functional objects that we can think about like components. Up top, we have a toaster oven and a toaster, both of which take in bread and electricity and give you toast. On the bottom, we have a coffee maker and an espresso machine, which take in water, ground up coffee, and electricity and give you coffee. The reason that we have all of these things in our kitchen isn't for what they are, but for what they do. And since both of these pairs of objects have the same inputs and outputs, or they fulfill the same interface, we can swap them out according to our needs. Some real code examples of what components could look like now that we've seen this example are different types of LiDAR, which take in light data, process it, and produce output, but they all process it in slightly different ways. So if that's what components are, then what are plugins? Plugins are dynamic libraries which hold components. They can hold just one, or they can hold many components. These dynamic libraries are something that you get when you compile your code, so they would correspond to a DLL file on Windows or a .so file on Linux. These plugin libraries are loaded up at runtime by the registry depending on what components you need in your code. Which brings us to our next question: what is the registry? The registry is what manages plugins in our application. So whenever a plugin is requested by the client, the registry loads it up. This can either mean that you asked it to load a specific library, or that you asked for a certain type of component and it automatically found the library that has what you need. The registry holds all of the factories for component instantiation, and whenever it creates a new component, it passes you a smart pointer handle to it. So the plugin library is the actual dynamic library file that the registry loads up, and once it's loaded, that information in the library file is used to create library and factory class objects. This is mostly hidden behind the registry, so you don't have to worry about it, but just so you know, a library object is what holds all of the factories for one plugin, and the factory class is what does component instantiation. It's what actually creates the objects. And once these objects are created, the registry hands you a smart pointer to the object. I think the best analogy for this setup is a library, but with one major difference. We have to pretend that all of the shelves are behind the counter and only the librarian can get stuff from them. In this setup, the librarian is the registry, and all of the shelves are the plugin libraries, and then the books on the shelves are the components. So we walk up to the counter and we ask for what we want. Maybe we have a specific book in mind, or an author or genre, or maybe we just want any old book. And we ask the librarian for what we want, and they look it up in the computer on their desktop, which is the catalog, which I'll tell you about in a second. So the librarian looks up your request and then goes to the right plugin library and grabs you the right component, the right book off the shelf, and then hands it to you. The way this is all organized is that there's a class one level above the registry called master. The master object holds the registry, the type master, which is a list of all the different types you can have in your application, and the catalog, which is a double key dictionary that lets the registry know where to find the factories to instantiate different types of components. The catalog allows you to look up components either by their specific name or using a special matching string that allows you to be as general or as specific as you want. Let's take a look at another book rental oriented example to get an idea of what I mean by that. I think the Dewey Decimal System is another good book rental analogy for how this string matching works. for those who aren't familiar with the Dewey Decimal System, the way that it works is each 100 level number is a big category, like literature or science or something. In this case, we're going to use literature as the example. All books that have a number starting with 800 are literature. And then as you move decimal places to the right, you get more specific. So books with a number in the 820s are English literature, and since Shakespeare wrote a ton of books, he gets an entire integer. Books starting with 822 are written by Shakespeare. And each book has a unique identifier that has a bunch of decimal places, as many as you need to fully specify the book. So you can either look up books by their title, or you can do varying degrees of specificity using the Dewey Decimal System. So if you just ask for a book in the 800, you might get any of the 6 of these. You could get Romeo and Juliet, or you could get Les Mis. If you ask for something in the 820s, you might get Othello or Harry Potter, any of those 4 in the inner circle. Or if you ask for something by Shakespeare, you'll get something that Shakespeare wrote. Or you can just ask for the book by the specific title. The way the catalog works is that each component is registered to a string. The format of the string is interface, class, organization, miscellaneous, where the interface is the interface that the component implements, class is the name of the component, organization is the group that made the component, so like Hive or a different group within our company or a university that's contributing to the project or whoever. And then miscellaneous is an optional token that allows you to add more things that you can match against in the catalog, just to widen the amount of specificity or generality that you can have when you ask for components. Some examples of this are vehiclei.sedan.sample, where this is a sedan made by the sample organization, which implements the vehicle-i interface. You might remember this component from the Interfaces and Abstractions video garage example. And then we also have vehiclei.airplane.planeplanes, which is an airplane made by the Plane Planes organization that also implements the vehicle-i interface. Here is our sample code. We start out by instantiating the master object, which we then use to get a pointer to the registry. If you'll remember, the master is what holds the registry, the type master, and the catalog. So once we have the pointer to this registry, we can run this application in 2 different ways. We're going to have a manual flag, which means that we want to load up libraries by specifically saying which libraries we want to load, or we can do auto load, which is where the registry will go looking for plugin libraries that satisfy our requests and load them up whenever we ask for components. We're going to start by going through this with auto load turned on, so just keep that in mind as we read through this code. The first thing we're going to ask for is a vehicle-i, which means that we just want any old component that implements the vehicle-i interface. We don't care what kind of vehicle it is, we just want a vehicle. And that vehicle will be passed to us by this smart pointer object. The smart pointer is going to point to the vehicle object that gets created, and we then need to check whether it's valid. And the reason for this is that when we ask for something from the registry by a string, there's a possibility that there's no component that satisfies our request. Say we ask for something like this, it's just nonsense. The registry is not going to find anything, and we're going to end up with an invalid pointer. So you always want to check to make sure that there's actually something there before you call any functions. Once we do that, assuming that it is valid, we're going to print out the string that we use to request that component, and then we're going to have the component print out its name. So this will tell us what kind of vehicle there is behind the scenes. Next, we're going to ask for a vehiclei.airplane. So we're getting a little bit more specific. We want something that satisfies the vehicle-i interface and is also an airplane. And then we're going to find out what we ended up with here. Next, we're going to do a vehiclei.sedan.star. The star works like a wildcard in regex, which just means fill this token in with anything. So we're asking for a vehiclei.sedan made by any organization. And then we'll find out what we get. Here, we're going to be super specific and ask for a vehiclei.sedan.sedanco. So we want a sedan made by the Sedan Co. organization that fulfills the vehicle eye interface. Here, same deal, but by the sample organization. And then here, oh no, I changed this. Okay, so here we want a vehicle eye. We don't care what class it is, but we want it to be made by the Planes organization. So the only thing that's going to fulfill this is the Planes airplane, but the Planes organization could conceivably make another type of vehicle. Like maybe they also make a helicopter that fulfills the vehicle eye interface. And this star would allow either of those to satisfy our request. So I hope that illustrates how the syntax works. Let's see what happens when we go ahead and run this. Okay, so for starters, we're just going to run this with autoload turned on, which means that it's going to automatically choose which plugin libraries we need based on our component requests and do things that way. So we can see right here, master was created, get a little printout for that. And then right here is where we request the vehicle eye component, and autoload goes ahead and grabs us the components plugins example dynamic library, which is the new dynamic library that we made for this example, which has the 4 new types of vehicle eye. So all of those are loaded up by the registry and ready to have those factories start making components. So when we request vehicle eye, what it gets us is the Planes company airplane. The way that it chooses which one to get us when there are multiple viable candidates is that they're like ranked by the catalog, and this one just happens to have the highest precedence. So then when we request the vehicle eye.airplane, we get the same thing. When we do vehicle eye.sedan.star, we get the Sedan company sedan. Same thing when we ask for the Sedan company sedan specifically. And then when we ask for the sample sedan, that one's not in the dynamic library we already had loaded up. So the registry goes ahead and loads up this other dynamic library, the sample garage example dynamic library. And then it's able to give us our sedan. And then when we do this last one, vehicle eye.star.planes, we again get the Planes company airplane. So I hope these 2 lines right here made sense, where it's automatically grabbing the plugin libraries that we need based on our requests. That is a really cool feature of Hive that you don't need to know where the components are stored as far as where the plugin library is or what the plugin library is called. You just ask for what you want, and then the registry makes sure that you get it. Going back to our code, let's take a look at what it looks like when we use the manual flag and we load up the plugin libraries by specifically saying which ones we want. We set this argument manual. You can run the program with this flag and it'll set autoload to be false. When autoload is false, we say that we're using manual plugin library loading, and then we load up this library specifically. And this library is the one that contains the 4 newer vehicle eye implementations that we made for this example. So when we run it, the registry is only going to have access to components that are held within this library. And one reason that you might want to do that, even though it makes fewer things available, it can be a good thing because it allows you to be less specific in your strings that you ask for. It can make your code look cleaner if you just have to ask for a vehicle eye.sedan because you know that there's only one. That is one reason why you might want to do this. But let's go ahead and take a look at what it looks like when we run it. You can see here I've got this manual flag. Let's go ahead and run it. You see here it is, using manual plugin library loading. So we load up that library that we talked about, and all of these things are in that library, so we found them just fine using these strings. But when we get really specific and we ask for the vehicle eye.sedan.sample component, that one cannot be found because we don't autoload the library. But just as long as you don't ask for things that you're not going to have, presumably when you do manual loading, you've thought a little more about what specific implementations you want, and you won't run into problems like this. But yeah, just to illustrate that that one's not available, we asked for it anyway, and we did not find it. And then on this last one, we have the Plain Planes Company airplane once again. We have one more slide here, just going to talk about the benefits of component-oriented design overall. So one big takeaway is that a benefit is being able to interchange functional units in our code. It makes it easier to adopt better technologies as they become available because all of your code is modularized at a functional level. And when a better version of LiDAR or a better tire model comes in, you can just load up different plugin libraries at runtime, and then you get to use them. This provides user-friendly access to all kinds of plugins and gives you tons of flexibility when you're creating your applications. So I hope you found this video helpful, and I will see you guys next time.